Okay. In this problem, we're being asked a question about the prices of new cars. Not everybody pays the same price for the same model car. And so, assuming that the price for this model car, assuming these prices are normally distributed, you have the average price paid for this model was $27,000, and the standard deviation of the prices paid was $500. And we're asked several questions about how much buyers paid and how many buyers paid percentage-wise between certain values for this particular model vehicle. And so part A asks us how many, as in a percentage, what percentage of buyers paid between $26,500 and $27,500. Now remember, normally distributed values, our normal distribution, it looks, if we put it on a graph, it has this bell curve shape to it, right? And kind of approaches zero as we go to either direction. And this high point is going to be our average. That's going to be our mean. And then we had the area under the curve is related to the percentage between values. And so what we're really given is that X bar, rather than writing that in as X bar, let's write that in as 27,000. And then we could say 27. And I'm just going to write this in terms of thousands. I don't want to write all the zeros in because I don't really have space to. I just erased more than I meant to. Let's go back and erase what I meant to. And now I'm going to have 27,000. And so we're going to say dollars in thousands. All right, so $27,000, and then we got 27.5 and 26.5, and then over here we'd have 26, and over here we'd have 28, and really my spacing's a little bit off here. Thousands. Go away. I did not mean to hit that. Go away. Thousands. And my tick marks on this, if I'm going to make this big, don't want to delete my sketch. I want to make this a little bit more accurate here as far as where my tick marks belong. And so then that'll be my, I'm going to zoom in so that I can write a little bit smaller here. That'll be my 27.5. That'll be my 26.5. Can't write anything right today. 26.5, and then 26, and then 27.5, and then 28,000. And the reason is, remember we have this 95, 99, 68, 95, 99.7 rule. And that refers to the percentage between plus or minus 1 standard deviation, plus or minus 2 standard deviations. And then if I go even further out, plus or minus 3 standard deviations. And again, I'm a little bit off here as far as the distances for my sketches here, but you'll see what I mean as I fill this in. So the space between this is plus or minus 1 standard deviation minus 1 standard deviation. And we say that 68% of our values occur between those 2 points. Then we say that 95% of our values occur between these 2 points. And so if I go a little bit below here, I'm just going to have to cut across the top there and say that 95% of our values fall between those 2 points. And then we'll go below the whole thing here and say that 99.7% 97% of our values fall between those 2 points, plus or minus 3 standard deviations. And so knowing their standard deviation is $500, what I can do is I can come up with some rapid approximations for these percentages of values in between my prices. And so using that idea, I'm going to go back and I'm going to reapproach this problem. My problem said I had between 26.5 and 27.5. Well, that's plus or minus 1 standard deviation. That's straight up from the 68, 95, 99.7 rule. That's just plus or minus 1 standard deviation. So that is 68% of my buyers will be between that, because that's plus or minus 1 standard deviation from the mean. 26 and 28,000 is the same idea. It's just plus or minus 2 standard deviations, because if a standard deviation is 1,000, is 500, then 1,000 is 2 standard deviations, and so it's plus 2 standard deviations to get up to 28,000, and minus 2 standard deviations to get down to 26,000. And so again, straight from the 68, 95, 99.7 rule, 95% of my buyers would fall into that category. This is where it gets a little bit different, and we have to think for a second about how we could apply this rule a little bit differently, because up until now, everything we've been talking about has been symmetric around the mean. And this question, Part C, is asking me between 26,000 and 27,000. And that's not symmetric around the mean. That's just this area. So if I go ahead and redo my sketch down here for this problem alone, it's just, if that's my mean at 27,000, and then over here at 26,000, that's 2 standard deviations below, so I'm going to put another tick mark there. And so if that's my mean, this is 2 standard deviations below my mean up to my mean. And so what I'm really asking about here is this area, which is not part of my 68, 95, 99.7 rule. It's, if I can draw on this without it getting too confusing, it's this portion of that rule. And some of you have probably already figured this out. What that means is, well, plus or minus 2 standard deviations would be 95%, and I'm covering exactly half of that. And so it's going to be half of 95%, and so it's going to be 47.5%. So since if I went out to 28,000, that would be 95%, and this is 1/2 of the 95%. This is going to be 47.5% of my data will fall between those 2 values, or my buyers will fall between those 2 values. And you can check that you can check my math by doing 95 divided by 2, and we get 47.5. Okay. Similarly, if we think about more than 28,000, let's redo the sketch and think about this again. And so if I think about more than 28,000, I've got my bell curve. I've got my average at 27,000. And then 1 step above that would be 27.5. 2 standard deviations above that would be at my 28,000. And so now I'm being asked about, and remember, this never actually gets down to 0. It just keeps approaching 0. What I'm being asked is, what's the area under that curve, basically? What's the percentage of values that lie above? So percentage of buyers above 2 standard deviations above the mean. Okay, well, I'm going to use the same logic, the same concept here that I did last time. I'm going to think about, oops, apparently I hit the undo button at the wrong time. I'm going to think about my 95, there we go, my 68, 95, 99, 7 rule. I'm going to draw myself a new bell curve here, a quick little sketch up here, so that I can see, all right, that's my X bar, and that's my plus or minus 1, plus or minus 2, plus or minus 3. Forgive the roughness of this sketch. That approaches 0, and then that's coming down to approach 0. And so what I have is, there's my plus or minus 1 standard deviation, and so that's my 68. Here's my plus or minus 2 standard deviations, and so that's my 95. And if I can shrink that down a little bit here, then I will redo this in 99.7, and so then that'll be my 3 standard deviations out. But I'm not being asked about 3, I'm being asked about 2, right? So I'm not going to fill that in, because I think that'll get a little bit more confusing. So there's my 99.7, goes all the way out to those 2. My 95, it only goes out to those 2. It's everything in the center out to those 2. And then my 68, it runs out to those 2. And so if I wanted to figure out what everything above one of these is, what would I do? Well, everything above and below this would be 100 minus 99.7. And so what I really want to do is 100 minus 99.7, but I don't care about this half that's down below. All I care about is this half that's above, so I divide it by 2. And because I'm ignoring the half that's below 3 standard deviations, below the mean, all I care about is the part that's above 3 standard deviations, above the mean. And so that's kind of an example. In this case, we're not at the 99.7. We're 2 standard deviations above the mean here, right? Because we're 500s our standard deviation. And so we're 2 standard deviations above the mean. And so we've got the 95%. And so 100 minus 95% would be 5%, but that would also include this tail over here. And I don't want that tail over there. But because this is symmetric around the mean, that means that there's 2.5% above 2 standards above the mean, 2 standard deviations above the mean. And there's another 2.5% below 2 standard deviations below the mean. And so all I care about is this 2.5% that are 2 standard deviations above the mean and above that. And so I have my 95%, and then 100% minus that to get both tails. And then to ignore one of the tails, I'm going to divide by 2. And that's going to give me 5% over 2. And that's going to give me 2.5% of my buyers for part D there. Okay. I hope this helps us see the types of reasoning that we can use this 68, 95, and 99.7 rule with. It's an extremely powerful rule, very useful for us in figuring out these kinds of percentages quickly.